Hello, everyone. My name is Rabia Kodapanakkal. I'm a postdoc researcher at Eindhoven University of Technology. And today I will be talking about how to take a psychological approach to understanding micro and macroscopic structures during the train boarding process. Bit of background. I'm working on a project where we are trying to develop socially responsible nudges at train stations. I work in an interdisciplinary team with researchers from the physics group, psychology group, and the ethics group. And my role is that of a psychologist, and I'm trying to understand how to apply a more psychological approach to pedestrian data or crowd behavior. And today I will be specifically talking about certain psychological tools that you could use to assess parameters at both micro and macro levels. So let me start with the kind of patterns that we are interested in. So we are interested in patterns that are self-organized. What this means is these patterns emerge through autonomous and self-reinforcing dynamics at the micro level. So these are changes that happen at the micro level, which have a more of an outcome at the group level. And for example, in this case, there's no one leading or telling people what to do. So these patterns uh, emerge with interactions within the crowd at the micro level instead of having a leader or someone telling people what to do. And our focus is mainly on the train deboarding process in the Netherlands, where boarders of trains usually wait while the deboarders leave the train. And this could also be seen as an example of self-organization happening because no one is telling people what to do. And there are relevant properties of this boarding group or crowd at both the micro and the macro level. So if you see the image on the right, on the top, you see a train. And you see some people waiting at the doors of the train that are shaded in blue. These are the boarders waiting to board the train. And in the middle of these two groups in blue, you see some deboarders that are leaving the train. And at the micro level, we can have a lot of parameters that we can measure in this situation. So, for example, what is the velocity of the deboarders? How much area is occupied per person, whether deboarders or boarders, and how much interpersonal distance do they have? So, how much space do they have with people who are around them? And at the macro level, so at the level of the situation or level of this boarding door specifically, there can also be some properties. So, for example, you can measure crowd density. And that would be at the group level. You can also measure the flux of this particular boarding situation. You can measure the flux of the deboarders, and you can also measure, for example, how much space are the boarders leaving to form a corridor. So you can measure the width of this corridor. Now, coming back to the micro level properties, it is also possible to measure these micro level properties at a macro level. So, for example, if you are interested in a particular door of the train or even a particular train, then you can average these parameters at the level of the group. So, for example, then you would have an average velocity for, say, door A compared to door B. So you could then compare whether one boarding group boards faster than the other, or one boarding group has more or less area per person than others. Like I mentioned, variation can occur at various levels. So at the micro level would be at the level of the individual or the person. So for example, person A could have, say, a different velocity compared to person B, but this could also happen at the macro level. So for example, the average of velocities at door A might be different from that of door B. And in psychological terms, we call this an individual situation interaction, where the individual is, of course, the individual, but the situation could vary. So the situation in this case could be a door of the train, or it could be comparing different trains, but it could also be other kinds of situations. So in this research, we mostly focus on different doors of the train. Another level of variation can be time, which luckily we have in our data. So we have timestamps. We have different timestamps for what is happening. So we can also see whether there is variation in, say, velocity or area per person happening over time, but within a particular boarding situation. And this variation at individual or situational level can be explained by a number of factors. Just to go through the factors, so for example, for individual variation, people can vary based on age or gender. Maybe this affects their behavior. People can vary on dispositional traits, so people can have different personalities. Some people may be more agreeable than others, some more impulsive than others. Some might care about reducing harm, and this may result in different behaviors. And they might have other differences. So, for example, people might have different goals or motivations. Some people might try to stand at the door, as close to the door as possible, because they really want to get a seat in the train. Some people only care about getting into the train, so they might be a bit more casual. This also affects this might affect the behavior. And this is not limited to these. So this list can go on and on. Similar for situational variation. This can be, let's say, for example, the width of the door changes. So some boarding groups might board faster than the others. Boarding locations might be different. So, for example, if there are obstacles on the platform, this might lead to different boarding speeds. The number of boarders could change in a group, maybe. So maybe if you're close to an escalator, maybe more boarders board from there. This could also affect certain behaviors. And things like time of day could also affect behavior. And this list also is not exhaustive. It can go on and on. So these are a lot of factors. Maybe it's good to look at them more systematically. So it might be useful to take a step back and first understand the extent of the variation and identify which sources of variation matter. So, does the individual matter, or does the situation matter? Or do both matter? Maybe both can explain the behavior. And once you have identified the source of variation, so let's say we see that maybe individuals matter more than the situation, then we can only focus on factors that explain individual variation. Then we don't need to look at factors that explain the situation. So this narrows down the number of factors that you might want to study. And once you then can explain this variation with certain factors, maybe the next step would be to see how we can change these factors to develop behavior change interventions. And sometimes you can also go straight from the first to the third step. So, for example, if you see that there's a lot of situational variation, maybe it might be a good idea to focus on the situation and maybe change something about the situation that might lead to behavior change. So how did we do this? So the method that we used, we had a data set available from pedestrian tracking sensors at the Utrecht Central Station in the Netherlands. And this data basically gave us the positions of people on the platform with a rate of 10 frames per second. So we really had a lot of data. And we made some inclusion decisions. So, for example, we only included the data points that were from 2017 to 2020 before the pandemic began, because, of course, patterns would change after the pandemic. So, we wanted to keep that a bit more constant. We focused only on the deboarding process. So, this would be from when the first person leaves the train to the last person that leaves the train. So, only this part where people are leaving the train and boarders are waiting. And we wanted to minimize a bit of the variance because the situation, you can decide how big you want the situation to be. We were interested in more of the crowd dynamics of how groups would interact with individuals. So we decided to minimize the variance by keeping the location of the data to a specific part of the platform. And with this, we got around 3,700 boarding deboarding situations. And we use this data set in a multi-level model. For those who are not familiar with multi-level models, basically a regression model where we have data at different levels. So you can have data at the individual level, but you can also have this data at the group level. And specifically for this research, we used what is called a variance components model or random intercepts model. And this is what it looks like. So for example, y is your dependent variable of interest. So this could be, I don't know, pedestrian velocity, area per person. It could be whatever is your main DV of interest. And the first term here is a random effects term that gives you the variance across individuals. So the individual ID would be the ID of different people. And this would basically give you whether there are differences across different individuals. The second term refers to variance across situations, and in this case, we used different doors as different situations. And this was not necessarily different doors of the same train. It was maybe one or two doors of the same train, but it was the same spot on the platform over time. So over like a span of 3 years for every day. And so we had a very, very broad range of situations that could happen here, but the situation was limited to the door. And luckily, we had an extra third term because we had data on different timestamps. So we could also see what was the variance over time and within situations. And these were the variables of interest we had. So one was Voronoi area, which is just the amount of area each person had. And we also averaged it at the level of the group. Then we had pedestrian velocity, and we also used interpersonal distance. So this was calculated as the average distance to 5 closest neighbors of the person. And we focused separately on borders and deboarders. So we did this multi-level analyses separately for borders and deboarders, and separately for these three variables of interest. The results. So on the x-axis, you see the percentage of variance from 0 to 100. On the right side, you see the legend of the components. So the residual is just an error term. The time frame is the variance over time. The boarding event is the door or the situation, so the variance that comes from the situation. And the pink is the individual variation, so how much variance is coming from individual differences. And looking first at borders, so the Voronoi area here, you can see, actually for all three, you can see that the individual variance is quite high. For interpersonal distance, it's individual variance and situational variance. The time frame variance is quite low, and for Voronoi area and velocity, even the situational variation is quite low. So you could say that it seems that over situations, borders seem to behave similarly while they're waiting. So I guess that's why it shows that they behave similarly. But there might be individual differences in velocity because maybe some people are moving, maybe some people want to try to get a better spot. So you see some movement. And I think the Voronoi area differences may come from the last row of people who basically have a lot of area behind them. So this may count as individual difference, although across the situations you see kind of the same behavioral pattern. Now for deboarders, this is slightly different. So you see that the individual variance goes down quite a bit, but even the situational variance is low. So this says that there is similar patterns across the situations, but also that the individual differences are not that much. So the deboarders don't really have that much individual differences that they show. But over time, there seems to be some variance. So this could be that over the boarding or deboarding situation, it could be that borders maybe move closer and then people have difficulty getting off the train or they get lower area. But this is something to then look into once you have this data. So this data does give us a lot to then see what we want to really focus on. The implications. So one thing that it really helps with is systematically developing hypotheses, especially with large data sets with many measures. Instead of really looking at correlations between different things, it might be useful to do this as a first step. Helps to narrow down and focus, and gives a broad idea about where you want to focus, whether individual, situation, or both. And this can also be very helpful for nudging and behavior change. So you can make decisions about where you want to focus your nudge. Would you rather target individual or the situation, depending on where there's more variation? So for example, if individual variation is super low, then there is no point targeting individuals for behavior change. Maybe your nudge should be more situation oriented. And just to tell you quickly about some next steps, we want to complement this real-time data, want to focus a bit more on psychological variables in isolation. So we are currently doing some qualitative research to understand individual motivation strategies. And then we want to incorporate these motivations into a network analysis or agent-based modeling. And for example, we would want to see, okay, if there's individual variation in boarding behavior, what factors underlie this? And we also want to focus on why deboarders are affected. So, for example, do waiting deboarders leave enough space for the deboarders even though they are waiting? And does this actually affect their velocity or flux or the speed at which they board? Thank you so much for your attention. And if you have any questions, you can either ask me now or you can send me an email or contact me on Twitter. Thank you.